Good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. For tonight, I will be discussing a long video format topic, and this is a continuation of my DC circuit long video format topic. Okay, let's proceed. The title of the subject matter for tonight will be DC circuit lesson number 26, and the title will be Delta to Y transformation. This is with regard to uh, delta loads to Y connected loads, because there is the so-called delta uh, power source, meaning transformer. We are not dealing for transformer for tonight. We are just dealing the delta to Y connected loads. Okay, to give you the summary of the formulas and how to convert delta connected load to its equivalent in terms of Y, I will be discussing the first figure here. The first figure represents the given delta load. The connection is delta. The terminal points are X, Y, and Z, and connected between these 3 points here, or three junctions, will be R1, R2, and R3. And for the next figure, this will be the equivalent Y load. So still we maintain junction X, Y, and Z. And represented here are the so-called Y equivalents. And the Y equivalent loads are actually R sub A, R sub B, and R sub C. Okay. Like what I said, on the past lesson, the main reason why we needed the conversions from Y to delta or delta to Y is actually to make a certain circuit more less complicated. Because sometimes if we are given a series parallel combination, or sometimes there are inserted resistances which are connected either in delta or Y, which will make the computation of the total resistance very difficult. Sometimes the proper solution is to convert some of those delta or Y for the given circuit to be less complicated. So that's the importance of the so-called transformation, like for tonight, the delta to Y transformation. Like for example, if the given circuit, there is an inserted Y, and it will make the computation of the total circuit, resistance of the total circuit complicated, we must have to convert that complicated thing to a certain equivalent, which will make the computation of the total resistance, okay, more easily for us. Okay, let's try to continue. For tonight, I will be giving you the transformation formulas, but actually there is the so-called derivation of this. So the next time around, I might bring out the derivation of the formulas we are using, because sometimes if we know how to derive, okay, our mind could handle it more easily if we know how to derive it. Okay, if you could not understand the derivation, it's fine. At least you know that the formula we are using are actually, they got a derivation. Okay, let's try to bring out the transformation formulas. The designations will be R1, R2, and R3. And these are the delta connected R's, meaning the first figure. R1, R2, and R3. The next one will be RA, RB, and RC. And these are the equivalent Y loads. So this equivalent here refers to figure number 2. Okay, let's now try to bring out the formulas on how to convert delta to Y. Like what I said, for simplicity, I will not be giving the derivation of this. I will just give you this. The next time around, I might give you the derivation. Okay, for RA, if we try to compute for RA, the numerator will be the product of R1, R2, R2, R3, plus R3, R1, all over R sub 3. For both RA, RB, and RC, the numerators are actually the same. So the only problem now is actually what will be the corresponding denominator that we will be using if we try to compute for RA. How come for RA, the denominator is R sub 3? How come for RB, the denominator is R sub 2? How come for R sub C, the denominator is R sub 1? It is something like this. If we try to compute for R sub A, this one. This is the Y equivalent, this one. The numerator will be the summation of the individual products of the three resistances, right? But to compute for RA, the denominator should be the resistance opposite to RA considering the delta connection. If this is RA, its opposite resistance considering the delta connection is actually R sub 3. That's why if we try to compute for R sub A, the denominators should be R sub 3. That's why the first formula, the denominator is R sub 3. If we try to compute for R sub B, where is R sub B? This one. Again, the numerator will be the individual product of each resistance, three values, RA, R1, R2, R2, R3 plus R3, R1, all over. If we try to compute for R sub B, the denominator should be the resistance opposite to R sub B, opposite, see in this direction. That was connected in delta. So if this is R sub B, its opposite resistance considering the delta connection is actually R sub 2. So R sub B, the denominator should be R sub 2. So this is R sub 2. For R sub C, the denominator or numerator rather is still the same. R1, R2, R2, R3, R3, R1. Okay? All over. So if we try to consider compute for R sub C, its opposite resistance considering the delta connection is actually R sub 1, right? This is the delta equivalent opposite resistance considering RC. Opposite. So R sub C, this will be the corresponding opposite resistance and the value is R sub 1. That's why in the computation for R sub C, the denominator is R sub 1. Oh, that's the only trick for the so-called delta to Y transformation. I will try to check my camera. Okay. Oh, that's the only trick. Because for the numerator, for both the three resistances in Y, the numerator are the same. We are given the individual products of each. Take the summation of that one. Same as for R sub B. Same as for R sub C. But the only trick is that in the computation of R sub A, we should refer to R sub 3 as a denominator. And for R sub B, the denominator should be R sub 2. And for R sub C, the denominator should be R sub 1. You can change the designation of this one. It depends on how you label your figure. I'm just telling you that if we try to compute for R sub A, the denominator should be R sub 3. If we try to compute for R sub B, the denominator should be R sub 2. If we try to compute for R sub C, the denominator should be R sub 1. Oh, that's the only complicated thing there. Because if you made the mistake on the denominator, of course, your answer will be wrong. Okay, so for now, we now know how to convert a delta connected loads to its equivalent in terms of delta by using these formulas. And I want to emphasize that the main reason why we need this conversion is actually to make a complicated circuit less complicated in the computation of the so-called total resistance. If a problem is asking for the total resistance of a circuit, and that circuit involves a delta connected resistances maybe, or a Y connected resistances. So at least you will be, what you call this, flexible in here. If the given circuit, we are given a Y connected resistances, and it will make the computation of the total resistance, what you call this, very hard. You need to convert that Y to delta. Or conversely, if there is an inserted delta connected loads, and will make the computation of the total resistance complicated, at least you know how to convert that delta to its equivalent in terms of Y for the circuit to be less complicated. Okay, so for those of you, that's the delta to Y transformation formulas, or what is, yeah, like formulas. At least you know how to memorize the Y to delta transformation formulas or delta to Y transformation. So for those of you who would like to subscribe to my channel is at youtube.com/@ProfDavidJ. If you want to share it, please click share. For those of you who do not know yet that my channel contains long video format topics, meaning long video format topics, it's the subject matter, it's a complete syllabus. I am telling you that I have uploaded already complete syllabus on differential calculus, integral calculus, differential equation, advanced math, AC circuit, this will be DC circuit, algebra, trigonometry, and analytic geometry. It's a complete syllabus. So if you are planning on taking up engineering, okay, this is good for you guys. Because it's a complete syllabus, at least from start to finish, that's the course. It's not a random topic, it's a complete syllabus, 10 subjects. And for my short videos contains electronics and some other topics. Okay, good evening from Los Angeles. This is Professor David J.